Hello, Math 7 students. This is solving two-step equations with manipulatives. We will be using our algebra tiles, so if you have your own set of algebra tiles, make sure you have those handy today. Otherwise, we will be using our online digital or virtual algebra tiles. To get started, you should have your worksheet that looks like this. We have access to that online, and we are going to be solving what we call two-step equations. You can see that there are two things that are happening to x here, and we're going to look at manipulating those first with our algebra tiles, and then we'll look at solving them without algebra tiles tomorrow. To get started though, think about what this is going to look like with our virtual manipulatives. We have 3x plus 3 is equal to 18. Coming on over here, that means when I'm getting my x tiles, I'm going to have 1, 2, 3 of those x tiles. Then it says we're adding 3, so that means I'm going to have 1, 2, 3 of these unit tiles. And on the other side, it's equal to and balanced with 18. So that means I need to pull out 18 of these unit tiles. So 3x plus 3 is equal to 18. And you might be confused about how to solve this. For some of you, it might be perfectly natural and you'll understand exactly what to do. But for some of us, it might be kind of confusing because we haven't seen problems that are like this before. We've seen ones like this, where we have our x tile, one single x tile, and some unit tiles. And you might remember that our process for those were just to pull off those unit tiles, right? We also had some that were like this, where there were no unit tiles, but there were multiple x tiles. And in this situation, all we had to do was group those into the same number of groups as there were x tiles, so that we knew that an x tile was equal to and balanced with 15. But we've got a different situation here now. We have multiple x tiles, so we're going to have to do some grouping, but I also have extra unit tiles too, which means I'm going to have to pull some of those off. So that's exactly what we do when we're working backwards. It's kind of a combination of both of these last two strategies, where we have our x tiles with the unit tiles. So work on getting the x tiles, plural this time. We're going to get our x tiles by themselves by pulling off, those unit tiles. Okay, so let's start with that. I'm wanting to get these x tiles by themselves, so I'm going to be pulling off 1, 2, and 3 of those unit tiles. But in order to keep things balanced, whatever I do to one side, I have to do it to the other side. So I'm going to be pulling off 1, 2, and 3 of those unit tiles. So what does that look like when you're trying to model this on your own paper? Well, it's going to look something like this, where I simply just X out the ones that I have taken off. Now our next step, notice that now these are gone, right? It's like our other problem, where now I have 3 of these X tiles, and those 3 X tiles are now by themselves because I've removed these unit tiles. Those 3 X tiles are equal to and balanced with, not 18, because we took these 3 off, but they're balanced with 15. So now we're going to do like we did before, and we need to regroup those. We need to put those into those 3 groups. So I'm trying to do my 1, 2, and 3 groups. So as I move these, 1, 2, 3, 1, 2, 3, and I'm just placing the remaining tiles that I have left into 3 separate groups. Which means, think about what this is going to look like algebraically when I don't have these algebra tiles. I'm splitting things into groups, or in other words, I'm dividing them into groups. So now I have an x tile that is equal to and balanced with 5 in the other side, 5 unit tiles. Therefore, we know that x is equal to 5. Here's our next one. 4x plus 1 is equal to 13. Go ahead and pause the video, set up your own virtual algebra tiles, and see if you can give that one a try. See if you can figure out how to solve it on your own. I'll show you the answers in a second, but I want to see what you can do on your own first. Pause the video now. Okay, and we're back. What you should have done is something like this. We start with our 4x plus 1 is equal to 13, but we want to be able to pull off that one unit tile, because that will leave me with just the x tiles. X isn't by itself, but just having x tiles is pretty close. So I pull off this one, keeping it balanced, I've got to pull off this one, which means it's going to look something kind of like this, where I've x'd those out that I already drew. And then we've got to regroup them. And so regrouping them, I've got 1, 2, 3, 4 algebra tiles. So that means I want these 12 remaining tiles to be in 4 groups. And it'll look something like this then once I've rearranged it. Notice I still have these ones that are x'd out, and I've just kind of redrawn where they are, my x tile balanced with 3 of those unit tiles. So that is the wrong answer. X is equal to 3. Pretty easy, right? It's going to be the same thing even when we're dealing with negatives. So on our next problem, 5x minus 3 equals negative 18. Just remember, minus 3 is going to be modeled with plus a negative 3, and it's going to be equal to and balanced with negative 18. Pause the video and get your own algebra tiles set up while I get my algebra tiles set up. And hopefully you've got something that looks like this. 5x tiles, or excuse me, I didn't get enough. There's 4 and there's 5x tiles and 1, 2, 3 of those negative unit tiles. And it's equal to and balanced with negative 18 of the unit tiles. Now remember what we have to do here. When we've got these negative tiles, in order to get rid of that negative, we have to have a positive added into it. Okay, so we've got our 1, 2, 3 positives that I'm adding in. Think about why I'm doing that, right? These create our zero pairs. And whatever I do to one side, I have to do to the other side. So I need to add in 1, 2, 3 positives. And notice that it's also creating some zero pairs over here. So when I get rid of all of those zero pairs, on my paper, I would have the equation that looks like this. But since I'm getting rid of those zero pairs, notice I've added in the zero pairs, but then I'm kind of circling them and crossing them out, reminding myself that those are zero. They're not part of that equation anymore. But look at what I've done now in these virtual algebra tiles. I've cleared off those zero algebra or the zero pairs off of my mat just because I can with the virtual ones. And now I've got 1, 2, 3, 4, 5 of those x tiles all by themselves now. I just need to figure out how to balance these 5 x tiles with these 15 negative unit tiles and 5 groups. So I want to split these into 5 groups. And notice that I actually kind of built it to be in those 5 groups anyway. So we can see that one of these x tiles is balanced with and equal to 3 of those negative unit tiles. Therefore, we have x is equal to negative 3. So the only thing that I want to caution you on is make sure that you remember that when I have negative unit tiles, the way that I get rid of those negative unit tiles is by creating zero pairs and adding in those positive unit tiles. Don't forget about those zero pairs. Go ahead and pause and give number 4 a try. 7x plus 2 equals 16. I'm not going to be showing you the answer here on the video because it's so similar to 1 and 2, and you already have the experience with that. So pause the video and do number 4, and then we're going to come back together and look at number 5, which is also pretty similar to number 3. That way you can see one more solved this way. So pause the video and set up your algebra tiles. 21 is equal to 2x minus 3. If you're ready for it, see if you can start solving it in addition to just getting it set up. I'm going to pause and set up my own algebra tiles while you pause and set up yours. All right, and this is what I came up with. I have 21 unit tiles equal to and balanced with 2 x tiles and 3 negative unit tiles, because minus 3 means adding a negative 3. Few things. So what that the x is on this side now? It doesn't really matter because it still is a balanced equation, and it doesn't matter if the scales switch places. It's still going to be balanced. So keep that in mind first of all. It doesn't really matter. Don't freak out about where the x is. Also, notice, how am I going to get rid of these 3 red tiles? Well, we get rid of those 3 red tiles by adding in enough of these positive unit tiles to zero them out. And whatever I do to one side, I have to do to the other side. So I added 3 to one side, adding 3 to the other side. So that's going to be our first step. Okay. Notice what happens. Again, those zero out, and here's the 3 that I added. So what does that mean now? Now I have 2 x tiles that are balanced with 24 of these. So knowing that I have 1, 2 greens on this right-hand side, now I need to set up 2 1, 2 groups with those 24 tiles. So think about what that's going to look like. It'll look something like this. Notice again, I've got those zero pairs pulled off the mat there, and I have x equal to and balanced with 12. So x is equal to 12. Number 6 is for you to try on your own. And now we're going to look at number 7, and if we have time, we'll also take a look at number 8. The key thing to remember here, well, before I even give you any hints, get it set up, okay? Just be careful because we now have negative 2x, which means as I'm setting up my algebra tiles, I'm not pulling out the green x tiles, I'm pulling out 2 of these. So negative 2x, 1 unit tile, and it's balanced with an equal to 7 of these unit tiles on the other side of that equation. Okay, so this is what it's going to look like. And our process is still the same. I've got a positive, so I can get rid of this positive by simply sliding it off the mat. Whatever I do to one side, though, I need to make sure I do it to the other side. Now I have, oops, haha, I didn't get enough of those. Let's count again. There's 6, there's the 7. So when I slide this one off, now I have those 6, okay? And we can see, hey, look it, they're already kind of grouped together. So one of these negative x tiles is equal to 3. Let's take a look at those steps over on the paper now. We have our negative 2x plus 1 equals 7, so we've got it drawn correctly here on the paper. I did do that one correctly. We have taken these off, so we've slid them off. So what does that mean? Look at, we've grouped these up now, but even though I know that one of these x tiles is balanced with 3 of these, notice that this is a negative x. So we have negative x is equal to 3. Think about what we did the last time we did this, okay? Where we had my negative 3. Oh, I'm not going to be too successful with this, I think. Okay. We have my x tile, negative x tile, balanced with an equal to, and I can't hold all 3 of them, one of these, 3 of these actually, okay? But I don't want a negative x. So instead of having a negative x, I need to flip it to get the positive. But whatever I do to one side, I have to do to the other side. So if I'm flipping this one, I have to flip this one. Okay, so yes, I might know what negative x is. I don't want to know what negative x is. I want to know what a positive x is. So we simply flip it, and we have a positive x is equal to and balanced with, it's going to be 3 of those negative ones. So remember how we modeled that before? We took the negative and we flipped it, right? So I've kind of drawn that flip sort of happening, and these 2 red negatives flipped to be positives, and these 6 positives then flipped to be negatives. So that means that one of these positive x tiles is balanced with an equal to 3 of those negative x tiles. So x is equal to negative 3. Pause the video, and I want you to do number 8. See if you can get number 8 completely set up, and then we'll go over how to solve that momentarily. Pause the video, get number 8 set up. Okay, and we're back. We're running short on time, so I'm going to go through this as quickly as I can. We have 15 is equal to and balanced with negative 4x minus 5. So I've got my 15 tiles here balanced with an equal to 4 red x tiles and 5 red unit tiles. So that next step is going to be, I've got to get in those 0 pairs. So I added in 5 yellow tiles, which means that I added in these 5 yellow unit tiles as well. Whatever I do to one side, I have to do to the other side. It just happens to be that on this side they zero out. So I've gone one step further. I've got all of these x tiles. They're at least alone. I just have multiple of them. So at this point we need to be grouping. So it looks like over here I've got 20 tiles. So these 20 tiles need to be regrouped into 4 groups. And so regrouped into 4 groups, and it looks like I did a little bit, a couple steps all at once. I regrouped them into 4 groups, but at the same time as I regrouped them, I also said, hey, that's a negative x, and I don't want negative x, I want the positive x, so I flip it, and I just kind of show that in one step there. So the correct answer would be x is equal to a negative 5. It looks like you have just one more problem that's going to require that flipping, so hopefully you can do that one on your own. We're really short on time, so I've got to skip ahead to x divided by 2 minus 1 equals negative 5. This is going to look like x that's split in half. So this is here to show you the whole x, but I don't have the whole x. This isn't really part of it. It's really just this x, but I'm keeping it there so that we remember that that would be the other half that's missing. Minus 1 is equal to negative 5. Remember how I'm going to get rid of that minus 1? That minus 1, sorry, move some things around. That minus 1, I'm going to get rid of by adding 1. Whatever I do to one side, I do to the other side, and notice that it zeroed out some tiles on each side. So now I have half of an x is equal to and balanced with 4 of those negative tiles. But what would happen if I had another half? If I had another half, that would equal a full. So that's what we're doing here, is I've got my half of an x that's equal to 4. My other half of an x would be 4 more, so when I put those together, I have 1 full x. So 1 full x is equal to negative 8 tiles. I know that was super brief, But that's the only one that you have, so you don't have to worry about having to figure out any others on your own. That's it for today, guys. Have a good one, and we'll be solving these without algebra tiles next time. I miss you guys. Please be safe, and hopefully we'll be seeing you soon.